Hello student. Now we are talking about the another type of isomerism is nothing but the conformational isomerism. Now what is the conformational isomerism? This isomerism refers to the different spatial arrangement of a molecule that arise from the rotation around a single bond. That is nothing but the sigma bond we can rotate. It means this isomerism is observed in the single bonded compound. These isomers are also known as the conformers and can intercount without breaking by a covalent bond, allowing for a flexibility in a molecule structures, okay, because of the single bond, and the ability to rotate freely around a single bond leads to a various conformers which can affect the physical and chemical properties of the molecule. So therefore, this conformational isomerism are nothing but there are two types. One is we called as the staggered, and another we can is called as the eclipsed conformation. So how we can understand this? So for that, the staggered conformation, I will take one example of ethane. Ethane, its structure is this. So I can write the Fisher projection of ethane so we can understand this properly. I can show these hydrogen atoms. This is the Fisher projection, structure of ethane. So here we cannot see this staggered and eclipse conformation. So for that, we have to write the Newman projection. So what the Newman's idea, we can discuss in the another lecture in detail, but here I can write the structure of according to the Newman. So you can take this front carbon by a dot. This is your front carbon, so it is a dot, and then you can show the rear carbon by using a circle. This was the Newman's idea. And then you can show these hydrogen atoms on a circle. For a circle we can show in this hydrogen. So this is the structure of Newman projection. Now you can see this, the distance in the hydrogen atom everywhere in the structure is the identical, means they are similar distance, they are from away from each other, so they have the minimum interaction here, okay, and this conformation is called as the staggered conformation. Okay, it is staggered conformation. Now I can write the same, its eclipse. How we can do this eclipse conformation? For that, just you have to rotate the rear carbon. So this is your front carbon dot. These are the three hydrogen atom. Then we can show a rear carbon, that is we are not. This is the rear carbon. This is the front carbon, and we are rotating this rear carbon through an angle 60 degree. So this hydrogen shifts here, this hydrogen shifts here, and this hydrogen shifts here. Now you can see these two hydrogen, they are approaching each other and they are coming close to each other, and that's why this conformation is called as the eclipsed conformation. Eclipse का अर्थ क्या है कि they are approaching each other, they are very close to each other, they are having the interaction, and because of this interaction they have the high energy, less stable. Here they are having the low energy, more stable. So this is all about the conformational isomerism, staggered it means the groups are, they are very similar distance from each other, and eclipse means they are approaching towards each others, and that's why they have the interaction, higher energy, less stable, and here is a low energy, more stable. So staggered conformations are more stable than the eclipse conformation, and this is possible, the conformational isomerism, in case of the carbon carbon single bonded conform. Thank you.